In the age of digitalization, many engineers have to consider which data structures best support their work. These data structures are then translated into specifications and implemented by software developers in various applications. This means that what the engineers have developed has far-reaching consequences. For these reasons, efforts are made to make it as easy as possible for them to define such data structures conveniently, for example, in a familiar environment such as Excel. However, if defining data structures is made too easy, it can become counterproductive. For example, here we see two excerpts from an Excel sheet that define data structures for the subsurface engineering. The table only specifies that the structure should have different levels. However, the meaning behind those levels can be interpreted differently. For example, in the top image, the tunnel section is at level 1 and the associated geotechnical unit is at level 2, which could mean that the section simply refers to it. The lower image is different. Here, we have specialized unit on level 1 and the geotechnical unit on level 2 again, but the meaning is completely different. Here, the geotechnical unit is a specialization or an extension of the specialized unit. We at the Vienna University of Technology have developed a tool, Excel to UML, that generates UML class diagrams from pre-formatted Excel tables automatically. Such tables allow the data elements to be related to each other in only a few well-defined ways: association, containment, and specialization. Being able to differentiate between these relationships largely eliminates any confusion based on conflicting interpretations of the table. This image shows an example where the tunnel section and various categorizations of the subsoil, for example in geological units, simply refer to each other via association. In this image, the tunnel section only refers to the geotechnical unit, but this contains the geological and hydrogeological unit via a containment relationship. This produces a much more restrictive model. And in this image, the tunnel section is divided into homogeneous segments via a containment relationship again. Each of these segments falls into a unit: geological, geotechnical, and so on. This is an aggregation relationship. This structure has a significant impact on the geometry of the tunnel. The main advantage of this method is that engineers can quickly try out different data structures. They can test many and select the most suitable one without programming knowledge and without the involvement of software developers.